Hello everyone, welcome to another video. In today's video, I will be showing you a real world project with the help of Terraform IAC, and I will be deploying resources into an AWS account. If this is the first time you have come to this channel, I already have deployed this project in one of my earlier videos, but at that time I used AWS Management Console or the UI, or we can say that I deployed everything manually at that time. So all I'm trying to do here is I want to automate that project. Okay. And I'm going to provide you the URL of that video in the description of this video. So if you're interested, you can take a look at that also. All right. So let's just understand the project's architecture, what we're trying to deploy here, and then I'll just dive into the demo. So in this project, I'm going to use one AWS region. In my case, it is going to be US East 1, but it can be any region of your choice. Okay. Which you want to use in your project. Within this AWS region, I will be using two availability zones. In each availability zone, I will have one public subnet. Okay. In each public subnet, there will be one AWS EC2 instance, which will be deployed. And these EC2 instances in the two availability zones will be part of an auto-scaling group. The auto-scaling group will be integrated with an application load balancer. Okay. And also, I will have one dynamic scaling policy inside my auto scaling group that is going to increase the number of instances from 2 to 3 uh, as soon as the average CPU utilization of this auto scaling group goes over 40%. I'm using 40% here just to trigger this scaling event a little faster. Okay, but in real world scenarios, or you can say in the real world situation, these this CPU utilization will be close to 70% or 80%, and you will have, I mean, you may have more than two EC2 instances as part of your auto scaling groups, as part of your auto scaling groups as well. Like you might have five EC2 instances running, and you can have it scaled from 5 to 7 in one go. Okay, as soon as the average CPU utilization goes over 70%. Just as an example, I'm giving you. But in my case, I'm going to use two EC2 instances, and I'm going to keep this average CPU utilization threshold as 40% so that I can trigger this scaling event a little faster. Okay, and so as soon as this scaling event is triggered, as part of this dynamic scaling policy, one more AWS EC2 instance will be provisioned, okay, in either of the two availability zones, because I'll be using two availability zones only. And also, this scaling event will be triggered with the help of a CloudWatch alarm. Okay, so I'll be using a CloudWatch alarm. Inside this CloudWatch alarm, I'm going to configure how this alarm should be triggered and when. So all that configuration will reside inside this. And also, we are also going to have one email as well. So I'm going to use AWS SNS, or simple notification service, that is used to trigger emails to a user email accounts. Okay, so I'm going to integrate this with CloudWatch alarm. So as soon as this alarm is triggered, okay, as part of the scaling event, we are going to receive one email as well on the given email in the configuration. Okay, so all this will be covered as part of this project. And the application that will be deployed on these EC2 instances, it is going to be an Apache based web server application. So the users can access the application on public internet, uh, because we are using an application load balancer that is internet facing. The traffic is going to be redirected from the application load balancer to these two EC2 instances. Okay, the EC2 instances are also in public subnet, by the way, and the website is hosted on top of these. Okay, also the application load balancer and the two EC2 instances, they will have a security group attached to them as well. uh, the EC2 instances will be created as part of a launch template that it will that will be inside of the Terraform script. Okay, the launch template will be attached to the auto scaling group. Okay, so this is how AutoScaling Group is going to create these two EC2 instances. Okay, in a real world scenario, you might have these public subnets as your private subnets. Means, I mean, in most cases, you won't be deploying this to a public subnet, but to a private subnet. Okay, but here I'm going to use the default VPC for this video. Okay, but in a real world scenario, you will use a custom VPC, and those custom VPCs will have private subnets as well. Okay, I'm using public subnets because in the default VPC you don't get private subnets. Okay, but since it is still a demo, so I just want to keep everything simple. But whatever is related to the real world situation, I'm going to give you all the details. Okay, and once again, this is a very good project if you can uh, do this via Terraform, and then you can explain it in an interview as well. So it's going to increase your chances of cracking the interview as well. Okay, so let's just start this project. And one more thing, uh, so all this work, because I'm using Terraform, so I will be using a Bastion host. Okay, or you can say like a gateway to deploy all these resources. So if I show you in my AWS account right now, I have one Bastion host EC2 instance, okay, which is already created. Okay, and I'm going to use this to run all the Terraform commands on this, so that I can create this project. Okay, let's just go through this GitHub repo as well, where I have included everything. Okay, so you can, I mean, go through this information. It will be available. So I mean, whatever is the project details, I have mentioned everything here, and I just want to cover some of the prerequisites that are required for this particular project. So, so all the things are mentioned in the GitHub repo, and I'm going to give you the URL of this repo in the description of this video. Okay, so I just want to explain you few prerequisites for this project. So, the knowledge of concepts that are required before this video have been covered in my earlier YouTube videos. Do check these out. So, as you know that we are trying to create a Terraform project, so obviously you should know about a few more things before you actually deploy this. So you should know how to create an EC2 instance from the UI or manually. Okay, so if you need any help, you can just check this video. Okay, where I've already covered everything. And if you want to know how to install and configure Terraform on an EC2 instance, for that also I have a video already, so you can go check that out. Okay, and as I mentioned, the entire AWS project that I am just about to do, I have already done this manually from the UI or from the AWS Management Console, and this is the YouTube video for that. And let's we can and next we can talk about the steps that you should follow to deploy this project via Terraform. So resources that should be provisioned before using the Terraform script. So if you're using Terraform, there should be uh, there are some prerequisites that you should already have, okay, before you can actually run this project via Terraform without any issues. So an AWS account is required, and you have to create one Bastion host, or you can say an EC2 instance. I'm going to use Amazon Linux 2023 operating system, AMI. If you want to use some other AMI, you can do so, but it would need some additional configuration as well. So just to avoid that and keeps things slightly simple, so that even the beginners can follow along, and they can learn the main concept of how to use Terraform to deploy this project. So I'm using Amazon Linux AMI. Okay, so you should have one Bastion host in an AWS account where Terraform is installed and configured. You should also have one SH key pair already created, which I have done in my case. It's going to be KP. Okay, try to use the same name because I'm using this in my main Terraform script file as well. If you use any other name of the key pair, you have to make the change in the Terraform script as well. Okay, remember that. Then you need an IAM role that is attached to your Bastion host with administrator access, because I will be using a Terraform from this machine via the CLI. So I would need some additional privileges to create all the resources. So to keep things simple, I'm using administrator access. attached to this IAM role, and this role will be attached to my Bastion host. Once again, if you need any help with IAM role creation, I already have a video on IAM deep dive concepts on in AWS, so you can go check that out. Okay. Also, AWS slash should be configured on the Bastion host. So once again, if you use any of the Amazon Linux AMIs, AWS CLI is already configured and you do not need to do anything additional. So it is already installed and configured to be used. So this is another reason I'm using Amazon Linux AMI. Then AMI ID should already be available to be used with the launch template. So in this video, I will be using a launch template which will be later attached to the AutoScaling group. So a launch template is going to provide the details to the AutoScaling group to launch the instances with some configuration, right? So, uh, so once again, if you need any help creation of this AMI has the web server configuration. So since we since we just want to focus on Terraform in this particular video, so I've kept that AMI ID creation part a little separate. So for that, I already have done one video that you can watch. How did I create this AMI, which has my web server configuration based out of Apache. So it is like whenever you use this AMI, you will have one ready to use web server, okay, that can deploy a particular application. Okay, so that application code as well is inside the AMI. So in this way, we can only focus on our Terraform script to deploy the project. We don't have to create the AMI once again. Okay, so as I mentioned, this video covers how to create this type of AMI, which can be used to deploy a web server based out of Apache, ready to use. So you can go check this video. Or there's one GitHub repo related to this video itself, where you can check all the details of how to create this AMI, which will be used in our launch template in this project. Then I already have two security groups already created. Okay, so I have created two security groups, one for each launch template and application load balancer. So the reason for doing that is point number 4. Okay, in point number 4, one more time. So I'm keeping it separate from the Terraform project so that when I destroy the project using this Terraform destroy command, the AMI is still available. Okay, so I'm keeping a few things separate from the project script so that I have that ready even if I destroy the project. Okay, so the AMI ID is 1 because I'm going to use it in some other projects as well. So I don't want to delete that. So I've not kept it as part of the project, but if you want to, you can do so. Okay, similarly, for two security groups that I use, launch template, one for launch template and one for application load balancer, I'm keeping these two security groups separate from the Terraform script. Okay, just because I use this in other projects as well. So I don't want to destroy it as when I run this Terraform destroy command to destroy all the resources of this project. Okay, if you need any help related to security groups, you can always refer to this video, which I've already done in the past. Okay. Then infrastructure is deployed in a default VPC and subnets that are available per region. So I'm going to use US East 1 in my AWS account, and I'm going to use two subnets, one each in US East 1A and US East 1B. Okay. Then an IAM role. You need an IAM role for enabling AWS Session Manager that will be associated with the two AWS EC2 instances that will be part of the launch template and auto scaling groups. So these two EC2 instances will be hosting your static Apache website. Again, I'm keeping it separate because I use this same role in some other projects as well. So I need to attach it to other EC2 instances. So I don't want to destroy this. And name of the role should be EC2-SSM. If you change this role name, then you have to make changes to the Terraform script as well. Okay. The next is, so I've just given some instruction for how to set up this AWS Session Manager. We need this AWS Session Manager so that we can SSH to our two EC2 instances as part of the auto scaling group, because we have to run the stress tests on the CPU so that we can increase the CPU utilization manually and we can trigger the scaling event and we can get the email as well. So all that has to be done. So you need to log into at least one of the two EC2 instances part of the AutoScaling group. Okay, so just to keep everything simple, I'm using AWS Session Manager, which is also part of the best security practices around logging into this EC2 instances. Okay, so in this case, you do not have to open any SSH port. You just have to create an IAM role for your EC2 instances, and you have to attach this a policy which is called Amazon SSM Managed Instance Core IAM policy to the role, and you need to attach this to the EC2 instances which are part of your auto scaling group. Okay, so that's why I'm going to use a session manager so that I can have access to the a session to the EC2 instances to run the stress test on the CPU. Okay, so you just need to create this IAM role and attach this policy and attach and just mention the name of the role as EC2-SSM in your Terraform script, and it's going to attach this role to your two EC2 instances. And again, if you're using Amazon Linux AMI, you do not have to do any other additional configuration because this. So you need Amazon SSM agent as well, so that you are able to create sessions on your EC2 instances. But if you use Amazon Linux AMI, you do not have to install any agent. Okay, but for other AMIs, you can refer to this documentation where it is given how to manually install this agent on any other operating system AMI. All right. The next is I'm going to access to my Bastion host, and then I'm going to show you how to actually run the Terraform script. Okay, so this is where our real thing starts. So let me just head over to my Bastion host CLI terminal, and I'm going to show you how to uh, run the script to automate this entire project. Okay, so here I am. I'm logged into the Bastion host, and I have switched to root. And if I do pwd, I have created one directory called Terraform. Okay, and as you can see, all the steps are mentioned on my GitHub repo as well. So you can follow that step by step to replicate everything that I'm going to do in this project. So access to your Bastion host and follow the instructions below. Become root, then create a directory, which I've already done. cd to the directory, which also I have done. Okay, and then the next is create the main.tf file. So I've already created a file to save on time. So this is the file that I've created, and I'm going to explain you the details as well, okay, in a moment. But I just want to mention another important thing, that when you're using this file, you have to fill out 5 placeholders in this file, which is a mandatory step. And these are the placeholders. Your AMI ID will be different than mine. Same, your security group IDs for your launch template and your ALB. You need to use your email ID in on which you are going to receive the email alerts. Okay, so it's going to be different for you. Similarly, for your VPC ID is going to be different. I'm using a VPC of my on in my account. So if you're using another VPC in your account, this ID is going to be different. So you have to make changes to these 5 placeholders for this script to run successfully. Okay. Now let's just go through this script. What I'm trying to do. Okay. So I'm going to use a Terraform AWS provider. Okay. The version is going to be 3.0 and above. Okay. I'm going to use AWS region, US East 1. And then I'm going to use this VPC. It is a default VPC in US East 1 region in my account, but you can use any VPC of your choice. As I mentioned, it's up to you. Okay. So this is what I'm using in my account. Then I'm going to create a launch template, and this is going to be its configuration. Instance type t2.micro, image ID is the image or the AMI that I want to use. Okay, as I mentioned, this AMI already has the Apache web server configuration. So when you deploy it on an EC2 instance, you will have one ready to use web server, okay, with a static website already configured on this. Then key name is going to be KP. So whatever EC2 instances will be launched using this launch template, the key will be KP. Okay, this is the name of the launch template. Similarly, I'm going to use a security group as well. So this security group is already existing in my AWS account, and it is going to be attached to any EC2 instance that will be created using this launch template. Then EC2 instances inside the launch template will have one volume, EBS based volume. Size will be 8 GB. Volume type will be GP3. Okay. Then I'm going to attach an IAM role as well, EC2-SSM, as I mentioned just a while ago. So this role is going to enable AWS Session Manager on EC2 instances that will be launched using this launch template. So I needed to perform stress test on the CPUs so that we can increase the CPU utilization manually, and we can trigger this scaling event. Okay. Then under tag, I'm going to use a tag as well for all the EC2 instances that will be provisioned using this launch template. Then similarly for auto scaling group, the minimum size is 2, desired capacity 2, maximum capacity is 3, and this auto scaling group will be creating instances in these two subnets. So this subnet is in US East 1A, and this is in US East 1B availability zone. And these two are public subnets and part of the default VPC in my US East 1 region. Okay, then I'm going to use the launch templates version, which is I'm going to use the latest version. In this case, there's only going to be one region, sorry, one version of it. So that's going to be the latest version, and that's what I'm going to use as part of my EC2 instance creation. Okay. The next is inside the load balancer. I'm going to use an external load balancer, means the internet facing load balancer. So internal is going to be false. It's going to be an external load balancer. Then it's going to be an application load balancer. And here I've mentioned the security group that I'm going to use. Once again, it's going to be different for you. Okay, I'm going to, I already have this security group created in my AWS account, and this is what I'm going to use. And subnets, I'm going to use the same subnets as I'm using with my auto scaling group here. Okay, so one in US East 1A and other is in US East 1B availability zone as part of my default VPC. Then the resources, once again, I'm going to use a target group that will be attached or associated with my load balancer. And this is the configuration. Name port is going to be 80 because I'm using Apache, which works on port 80 by default. It uses HTTP port. So that's what I'm trying to configure on my target group, which is going to have the EC2 instances as its targets. Okay. Then I'm going to use the same VPC ID as I've used previously in this Terraform script, so that I have all the resources in one VPC only. And the target type is going to be instance because I'm going to attach auto scaling group to this load balancer, which will be associated to this target group. Then this is the listener configuration on the load balancer. Okay, it's going to be port 80, port protocol HTTP. All right. Then I'm going to forward the traffic. So whenever the users are trying to access this website using the load balancer DNS, the traffic is going to be forwarded to the target group, okay, which is going to have our two EC2 instances, okay, which is going to serve the static website. So the load balancer traffic is going to be forwarded to the target group here, and it is the same target group that I have already defined in my earlier configuration in the Terraform script. Okay, then all I'm trying to do is I'm trying to attach this auto scaling group to the ALB here. Okay, so when you are attaching your auto scaling group to ALB, it uses a target group of the application load balancer. Okay, so here you can see I'm getting this AWS auto scaling attachment resource, and I'm attaching it to the application load balancer, and then I'm specifying the name and the configuration of the target group that is attached to the application load balancer. Then auto scaling group policy. So this is where you define the dynamic scaling policy to increase the number of EC2 instances from 2 to 3. Okay, so this is the name of the scaling policy, and then you can say adjustment type is going to be change in capacity. Then cooldown period is 300, which means uh, the scaling event is, I mean, if one scaling event is triggered, then other scaling event will be triggered only after 5 minutes. Okay, and it is going to be, this scaling policy will be attached to this auto scaling group. Okay. Then I'm going to specify the CloudWatch metric alarm. So here I'm specifying all the information related to my CloudWatch alarm as part of my scaling event configuration. Okay. So this is the alarm name, then comparison operator. So all the fields that you see from the UI are specified here. Okay. It's the metric that I'm going to use is going to be CPU utilization. Namespace is going to be AWS EC2. The period is going to be 60 seconds. When the alarm is triggered, it should be there for at least 6 seconds for it to trigger the scaling event. Okay. The static is going to be average because I'm going to use average CPU utilization of the auto scaling group. The threshold is 40. So as soon as this average CPU utilization of the auto scaling group hits 40, it's going to increase the number of EC2 instances from 2 to 3. So as I mentioned, in real world scenarios, you will have it like 70 or 80, and you can have more than one EC2 instances attached to the auto scaling group as well, depending on a particular use case. Then what's going to be the alarm action? I've specified here. Okay, so alarm action is going to be an auto scaling group policy that will be triggered, and a new EC2 instance will be created. Okay, so all the things related to the auto scaling group is configured here in the resource section of the CloudWatch metric alarm. Then, as I mentioned, this alarm is also going to send an email notification to the user. So I'm going to create one SNS topic. So topic is like a resource that you create in SNS, and whosoever subscribe to the topic is going to get the email. Okay, so that's what I've configured here. Then this is where you create the subscription to the topic. So after getting the topic, you have to subscribe to the topic to receive the email. So what email you're going to use, what protocol you're going to use, all that is defined in this SNS topic subscription resource block. Okay, so endpoint is going to be this techapricate at gmail.com in my case, but in your case it's going to be different. I'm going to use protocol email-json. I'm not using the standard email protocol because I tried with that, but I'm seeing some errors. So I'm using email-json. Okay, so the only difference is the output is going to be in the JSON format instead of the plain email that you see. Okay, so that's the only difference, but it works. So I hope this Terraform script is absolutely clear to you. It's a pretty simple one. Okay. If you still have doubts, you can always reach out to me in the comment section. So this is a Terraform script that we're going to deploy to automate our project. Okay, so let's just come out of it and let's start the process of using this Terraform script. So I already have this. So I just have this one file, main.tf. All right, there's nothing inside it. And if I go to my AWS account as well, let me show you what all we already have. So we just have one EC2 instance, right? Just one EC2 instance is there. And if I go to launch templates, you won't see anything. So there's no launch template at the moment. If you go to key pair, there's only one key pair that I've already created that I want to use as part of my Terraform script. I don't have any load balancers, right? I don't have any target groups. So all this will be deployed by the Terraform script. I don't have any auto scaling groups, right? If I go to SNS, you can see I don't have any topics, 0 topics. Okay, subscriptions I have, but these are deleted. So uh, these cannot be used. So, okay, so I don't have anything here. If I go to CloudWatch, I can show you what all alarms already have. Okay, I'm using US East 1 region. Everything is in this region only. And if I go to all alarms, I won't see anything. So there are no alarms, right? So nothing is there at the moment, but once I create the resource using Terraform, you will see everything here. Then in terms of roles, I have this EC2-SSM role that is attached to my Bastion host. It's attached to my Bastion host here. Okay, you can check that EC2-SSM, and these are the permissions that are attached to it. Okay, that's pretty much what I already have. I think we are good to deploy the project using Terraform. Okay, so The first command is going to be a Terraform init command, which is going to initialize your Terraform backend. So whatever providers you provide in the configuration file, it's going to be initialized using Terraform init command. Okay, so you should see this message, Terraform has been successfully initialized. I do lsf and la, I can see this .terraform directory created, and this .terraform.log.html file also created after I run this command. Okay, next command is going to be Terraform validate, which is going to validate the syntax inside the Terraform script files. So it's going to be Terraform validate success. The configuration is valid, which means that there are no syntax errors in the main.tf file that I have. Okay, then I'm going to run Terraform plan command. It's going to show us like a dry run of the resources that you're about to create. Okay, so you can see what all it's about to create using Terraform plan command. You can go through this to understand what you're about to do as part of creation of the resources. It's going to create 10 resource. It's not going to change anything. It's not going to destroy anything. Okay. So next is Terraform apply command. So now we know that we are going to create 10 different resources, and this is the details. These are the details about those 10 resources. So Terraform apply is going to create these resources now, but it's going to ask me for confirmation once. Okay, it's going to just have it like a confirmation it wants. So I'll just type yes here, and then it's going to start to create all the resources in my AWS account. Okay, so the Terraform script has started running, and it has started to create the different resources. Okay, so after about 5 minutes, it created all the resources for us. So we can see apply complete, resources 10 added, 0 changed, 0 destroyed. So let's see in our AWS account if those resources were created correctly or not. So this is my AWS account, and let's just refresh this window and see the 2 additional EC2 instances, right? So you have 2 EC2 instances created. If I go to launch template, we can see, I'll just refresh the window here, and we can see one launch template also created for us. Okay, and all the configuration that we specified is part of the launch template. You can verify that. AMI ID, instance type, key pair name, security group. Okay, so all is configured correctly. Then if I go to load balancers, you can see one load balancer created. Okay, it's active. And if I click on it, and if I see the availability zones, it's is what we configured. US East 1 in US East 1A, another in US East 1B. All right, and if I check this listener section, we can see we are using this protocol port, HTTP port 80, and the traffic is being forwarded to this target group. Okay, which we specified. If I click on it, it's going to open in another window, and you can see the details of this target group. So it has everything that we need. Okay, all that we configured is part of this, and we can see the 2 EC2 instances part of the AutoScaling group have been added, and since it is using the AMI, which already has Apache configuration ready to use, so it's able to pass the health checks as well. Health check is configured on the default port 80. Okay, the port is going to be the traffic port, which is port 80, and it is passing the health checks. You can see the 2 instances are healthy, right? If I go back to the load balancer, and if I have to check the configuration of my website, if I have to check if the website is actually running, so I can just copy this. Let's open an incognito window and try to access the website. It's going to be a unsecured site because I'm using HTTP and not HTTPS. So click on continue to site, and you can see the site is also loading. So we are able to deploy this project with the Terraform script successfully, right? The other thing that we have to check is if we are able to receive the alert when the CPU utilization hits 40% in the auto-scaling group. The average CPU utilization, whenever it hits 40%, it's going to trigger a scaling event, which means that it's going to increase the number of EC2 instances in the auto-scaling group from 2 to 3. Let's check the current number of EC2 instances first. So one auto-scaling group also created, and you can see instance management. You have two instances at the moment, and when the scaling event is triggered, these instances are going to be 3. All right, and you can go to automatic scaling, and you can see everything is also configured. So all the scaling policy was also created via Terraform script. Okay, so everything is looking absolutely perfect for us. So let's just verify if uh, the CloudWatch alarm was created. So you can see the CloudWatch alarm. It was also created. Okay, and you can see the CPU utilization, the conditions for this CloudWatch alarm to be triggered. The CPU utilization should be more than or equal to 40% for one data points within 1 minute. Okay, and if I click on SNS as well, so you can check one SNS topic was also created by the script. And if I click on it, you can see the subscription as well. So subscription was also created via the Terraform script, and you can see the status is pending confirmation. So this pending confirmation means that the email was triggered to this email ID to confirm whether you want to receive the alerts or not. So let me go to my email account, and we can see one subscription confirmation email. So this is all done by Terraform. Okay, and this, when you click on this URL, you will be subscribing to this topic that you have created. So this message means that you have successfully subscribed to the topic. So as soon as any message is published to the topic, you're going to receive the email alert. Okay, all this is done. Everything looking good. So now if I just refresh, you can see it is confirmed now. Okay, so this subscription has been confirmed, right? And if I go to my GitHub repo, I have mentioned everything in every detail that you need. Okay, so everything is mentioned here. What all you have to check, what all you have to see. Okay, so after running this command terraform apply, you have to head over to your AWS management console to see the created project resources. Then copy the load balancer DNS and try accessing the website on the browser. Test if it loads. We just checked the website is loading correctly. Please confirm the AWS SNS topic subscription by checking your email, which I already did. This will ensure that you receive the CloudWatch alarm based alert email as well. Then next is I'm going to SSH into one of the two EC2 instances from the AutoScaling group via AWS Session Manager, and then I'm going to run the following commands to stress out my CPU utilization. Okay, so let's do that. So let's go to my instances section, or we can go to AutoScaling group instance management tab and click on any of the two instances. Let's use the first one. I can click on connect. I can use Session Manager here to connect in the browser. So I don't have to use any SSH client application. This is actually the best practice around logging into an EC2 instance, especially if it is Linux and you just need the CLI. It is the best practice to use AWS Session Manager. Okay, so all this is configured on the Amazon Linux AMIs. Now I will become root, and I'm going to install this package called Stress. Okay, the package is already installed. That's good. Next is I'm going to stress out the CPU. So copy and paste, execute. So this is going to start increasing the average CPU utilization of the auto scaling group. Okay, so you just need to wait for a bit, and you will see one email triggered to your one alert triggered to your email because you've subscribed to the topic. Okay, so as soon as the CloudWatch alarm is triggered, the scaling event is triggered, you will see one email with the alert saying that the threshold of average CPU utilization of 40% has been breached. Okay, so we just need to wait for a bit. So after like a couple of minutes, the email alert has been triggered via SNS. I can check that. So you can see the email is triggered. It clearly says that the threshold crossed for one data point. This average CPU utilization was over 40%. Okay, it was over 40%. So the alarm was triggered. Okay, so all is looking good. The alarm is triggered. Now let's check our auto scaling group, whether the instances have been changed from 2 to 3. So let's just hit refresh. This is the auto scaling group instance management section. Click refresh and you can see 3 instances now. Okay, so from 2, we have increased the number of instances 3 automatically using the scaling event that was triggered via the CloudWatch alarm. Okay, and if you go to alarm section as well, let's go to CloudWatch alarms, all alarms, and you can see the state is an alarm, which means the alarm has been triggered. Okay, so we have been able to deploy this project via a Terraform script. So a lot of things were done uh, automatically by the script. All right, so the resources have been created. Now it's time to destroy the resource. So after you have completed the project, I recommend that you do destroy all the resources if you are not going to use them any further. Okay, so for that also, I've mentioned everything here. You can run the Terraform destroy command. So let's copy and paste this command on the terminal. Hit enter, and it's going to destroy all the resources. Okay, the resources that were not managed by the Terraform state, only those resources will be left. Okay, so let's just confirm that yes, I want to destroy all the resources of the project, and it is going to start destroying the resources for you. So you will have a clean AWS account. Okay, so I hope you like the video. Uh, I mean, I saw some requests, especially for this project, that they wanted to have this entire project automated by Terraform. So I've done that. I hope you all liked the video. If you did, please hit the like button. Please share this with your friends and colleagues. And please do subscribe to my channel. All right, guys, that's all I wanted to cover in this video. And I'm going to see you in the next one.